Hi everyone, I'm going to show you some examples of sampling using two questions. The first question is, consider a continuous random variable x that is uniformly distributed in the interval 5, 10. That probability density function of x is given by y equals 1/5 between 5 and 10 and 0 otherwise, which proves that we have a probability density function, especially if the area under that function is 1. Question A says, sketch the graph of the probability density function f. I've gone ahead and cheated and I've sketched mine in Desmos. And here it is. That is the function of y equals 1/5 between 5 and 10, which is obviously a linear function that if we filled in the area underneath it, we would have a rectangular shape. So that is representative of the whole population. Whatever the population is, we don't know. Question B says, simulate the selection of a random sample of 25 from this random variable using appropriate technology, that being our graphics calculator. So I'm going to choose 25 numbers between 5 and 10 and see if this sample represents that rectangular shape that we saw from the whole population. So opening up my calculator, starting from the beginning, we say math, probability, random integer. This time I want repeats because there's not enough numbers between 5 and 10 to hit 25 numbers. So I'm going to have repeated numbers. So don't choose option 8 that says no repeats, choose option 5. We want numbers between 5 and 10, and we want 25 of them. And if I paste that into my calculator and hit enter, I get 25 randomly generated numbers with repeats between 5 and 10. That's question B completed. Question C, construct a histogram or dot plot of the data and compare it with the graph of the function, actually depends on me performing B and C at the same time. So I'm going to go ahead and start again, question B from the beginning, but also perform C at the same time. That's why it's always a good idea to read through your entire question before you start answering it. So if I go back to my calculator, once again, math, probability, random integer, 5, 10, and 25 is what we want. And now before I hit enter again, I want to make sure that I store my values somewhere so that I can make my histogram in my calculator. Of course, it would be possible to go ahead and plot 25 numbers on a histogram using pen and paper. It probably wouldn't take that long, but let's see how to do it in our calculator for in case we have to do a lot more values than 25 next time. Because I want to store these numbers, I'm going to hit store, which gives me that little arrow, and then I'm going to tell the calculator where to store it. So second function list 1 is where I want to place these values when they're generated. Now I have a statement that says random integers between 5 and 10, 25 of them stored in list 1. Let's go. There they are. I've got double ups. They're all between 5 and 10, and there's 25 of them. And if I have a look, I can see those exact same numbers listed there in list 1. Those are the same 25 numbers that I just generated. They've been popped into that list automatically for me so that I can now use them, plot them, or manipulate them in some way on my calculator. So now I need to make my histogram. To do this, I go to Stat Plot, choose plot number 1. If it's already turned on, you can leave it. If it's turned off, turn it on. Mine is already turned on. Mine is also already selected as a histogram. I want list 1 values to make that histogram, and the frequency is 1. So now I can hit graph. And there they are. Those are my 25 numbers between 5 and 10 and the frequency at which they occurred. You can see that that is not reflective of the rectangular shape that we saw of the whole population. So I would go so far as to say that this population sample size may not be big enough to be accurately reflective of the whole population. But to prove that, I would probably repeat that process 2 or 3 more times and see what kind of outcomes I get. If I continue to get this random shape, I would definitely say that the population size is not big enough to be reflective of the whole population. And that's a summarization that we can make from this process, which is good because if we have a look at questions D and E, that's exactly what we need to do. It says to simulate that selection a few more times and then to comment on the variability of the 3 random samples. So I would expect to get that same random shape a few more times, and then I would say that that sample size is simply not big enough to accurately reflect that whole population. Let's have a look at another question. It says, consider a continuous random variable x that is normally distributed with a mean of 110 and a standard deviation of 15. So this time our whole population, again, we don't know how big it is, but we do know that it has a bell curve shape and it is normally distributed. A, simulate the selection of random sample of 50 from this random variable using appropriate technology, again, that being our graphics calculator. I'm going to go ahead and read question B as well, just in case I want to perform both of those tasks at the same time. It says, construct a histogram or dot plot of the data and compare it with the graph of the probability density function of x. So remember that the graph of the probability density function of x is a bell curve. So we would expect that a good sample would also have a bell curve shape. So let's give it a go. Back to my graphics calculator. I'm going to clear everything back out of it. And I'm going to start again. Math, probability, random normal this time because we're told that the distribution is normal in our question. We have a mean of 110, a standard deviation of 15. I want 50 numbers generated. And once again, before I go ahead and generate those numbers, I'm going to go ahead and store them somewhere so that I can answer question B. Store, list 1. Go ahead. All right, so it has gone ahead and chosen 50 numbers between 121 and 99 approximately. If I have a look in my list, I can see them all there. There's 50 numbers. I'm going to trust that there are 50 there, but there's 50 numbers randomly generated from that data. So looking at the numbers, they look about right. They look like they would probably have a mean of 110 at a glance. I don't have any alarm bells ringing because I've got numbers as big as 1,000 or as small as 2. It all looks pretty good to me. So let's go ahead and create a histogram exactly the same way as we did before. Stat plot, plot number 1, turn it on, choose a histogram, list 1, graph. Now, if your graph doesn't show you your histogram, we can just zoom with zoom stat and it will find it for us. There we go. And I'm actually quite satisfied that that is relatively normally distributed. I'm going to go ahead and do it again so that I can make sure that I'm making a proper judgment about that call. There we go again. That's my second trial, also somewhat normally distributed. If I did it again, I would probably expect to find another normally distributed histogram. You would want to do at least 3 trials to trust your own judgment. So I would go ahead and say that questions C and D, the variability of the 3 random samples is actually quite good. That 50 seems to be a good sample size because my samples all somewhat match the shape of a bell curve. Let me know if you have any questions.